Hi, this is a video overview of Thrust Doll, my work in progress game project. I've been working on this project since December 2022 as part of a bootcamp course run by an organisation called Mastered. The concept for Thrust Doll is a 3D bullet hell speed game in which you play an acrobatic cyborg attack doll soaring through a hostile biomechanical environment. Its aesthetic inspirations are works like NieR, Blame, and Ghost in the Shell, as well as the illustrations of Katsuya Terada. Its movement mechanic concept, where you combine a thruster and a grappling hook, is inspired by Spider-Man, Attack on Titan, and the Scout in Deep Rock Galactic. Thrust Doll is created almost entirely in Unity Dots. Dots is an entity component system framework designed to optimize memory access patterns and take advantage of parallel processing as much as possible. It's a very new feature of Unity that has become 1.0 just this year. Since Dots is not yet complete, I have used the Latios framework by Dreaming 381 to provide features like hyper-optimized animation sampling and spatial queries as an alternative to the default Unity physics. I designed, modeled and animated the Thrust Doll cyborg character in Blender. My priority was good animation topology and appealing hard surface designs resembling 80s Japanese sci-fi illustrations. I ended up with a kind of insectoid shape. The model was rigged using Blender's Rigify plugin with additional weight painting to improve deformation. My first project was to create a configurator screen for my character, where you will add or remove cyborg parts that give you powers in the level proper. This gave me an introduction to Dots, and ideas such as rendering interface elements with billboards were something I came up with at this point. The center of this demo is the movement system. I've implemented thrusts and kicking off walls with full animations. The player aims with the mouse and clicks to initiate a thrust. Depending on the direction change, the doll might make a small adjustment, or it might perform an Immelman turn, or if you're a swimmer, a tumble turn. I wanted the environments to feel like a womb or a cave, blending organic and mechanical elements. They're not quite there yet, but I've got some very cool technical features to talk about here. I created a system for rendering levels by ray marching sign distance fields. The same sign distance fields are used for collision. Presently, the levels can only be made out of spherical metaballs, but this method can be extended to all sorts of shapes. Metaballs can be placed in the Unity editor and then they're copied into a shader and used for rendering. When the doll is near to a wall, she will enter a dynamic animation blend where she anticipates kicking off that wall. The progress of this animation is directly controlled by the distance from the wall. If she gets close enough to collide with the wall, she will kick off of it and her velocity will reflect like a laser. This leads to an interesting emergent behavior where she seems to scamper along a curved surface. The bullets in the game are quads with the procedural billboard shader inspired by the bullets in NieR. The shader uses one noise sample to distort the polar coordinates of a second noise sample. If the player is hit by one of these bullets, time slows down and an animated UI toolkit interface displays the failed result of the level. I have written a very detailed devlog of all the decisions in my game, linked in the description. You can also view all of the game's source code on GitHub. Unfortunately, it is not possible to give a playable build of this prototype due to a Unity bug that has to do with linking a certain library that's needed by Latios framework. However, I'm very much looking forward to when I can release a build and have other people play this game. I'm definitely going to be continuing work on Thrust Doll, but I'm proud of what I've been able to accomplish so far at Mastered.